Hey guys, welcome to EOC Explained. Let's rock and roll. Alright, we're going to go over question number 8 today. Number 8 is about genes and what happens when they get passed on. Give you guys a second to read that. Go and pause if you want. Otherwise, let's rock and roll. Alright, so number 8 says this. Some organisms have genes that improve their ability to survive and reproduce. If the genes also help their offspring survive and reproduce, then which of the following will most likely increase? Okay. So first thing we're going to do is what awesome people do, and that is highlight stuff in the question. It helps us organize our thoughts. Next is we're going to kind of arrange those thoughts right in front of us. Make it easy. So number 1, what do we know? Genes help them. Awesome. That's the first highlighted point. Number 2, what do we know? Genes help their offspring. What's their offspring? Well, that's their babies, right? Okay. So what are genes? Genes are essentially your blueprints. So if you have blueprints to a house, and that house is well put together, you're going to have an awesome house. If you have blueprints to another house and the blueprints are bad, you're not going to have a good house, right? So let's look at some of these questions. We're going to go ahead and start with J and H. So essentially both of those follow the lines of it increases the number of genes. Well, we know that you have a certain number of genes, and your number doesn't really change. Now, generation to generation, that the type kind of changes, but the number doesn't change. That'd be like if I have a really awesome car, I have the blueprints to a car, and hey, everybody loves this car. So once I make it once, then I start stacking blueprints on top of it. That's not the same car. It's not a good car anymore. So we don't change the number of genes. That doesn't work. Your gene number does not change, okay? So let's go ahead and eliminate J and H. No good. Okay. Alright, so what's most likely going to happen when you have a really good trait in a population is looking at F and G. Let's look at F first. The frequency of genes will change in one individual. So in that case, we have a good trait. Let's say you have a cheetah and the cheetah is super, super fast. So it can, as our thing that we highlighted said, it can run away from maybe lions so it can survive, which gives it a better opportunity to reproduce, right? So in that case, it would only go from individual to individual, and that's not really going to spread it out. It's not really going to increase the frequency at all. It's going to maintain the frequency, but it's not going to increase, right? But most likely what's going to happen is if something has positive genes that help them, if there's 10 cheetahs and one of those cheetahs can run faster, well, then it's more likely to catch food. Therefore, it's more likely to eat and be healthy to do that again. It's also more likely to escape any kind of predator or anything attacking it. So if there's a lion around, the fastest cheetah is pretty much guaranteed to survive, where the other ones are not necessarily guaranteed. Which both of those in turn increase its chances to reproduce and pass on those genes, right? So I give you an example. Let's say we got a frog, and we're accustomed to a bunch of green frogs, but let's say there was a red and a purple frog too. Well, let's say their environment is green grass. Well, in a green grass environment, predators that eat them, let's say certain birds that eat these frogs, well, they probably won't notice the green frogs. So chances are those green frogs will live a little bit longer and have more opportunities to reproduce. In other words, have babies. And those babies, therefore, are more likely to have the gene of greenness, right? So in that case, they would increase that gene in the whole population. So in the population as a whole would get that trait. And the red frog and the purple frog are more likely to, well, get spotted and then, of course, get eaten. So they're probably not going to reproduce. Now, that doesn't say they won't. That doesn't mean to say they won't, but it's very unlikely. And therefore, eventually, let's say originally there was this many frogs. Well, over time, it's probably going to start looking like this. Pretty much all green frogs, because they have, as we said, increased chance to eat, increased chance to survive, and increased chance to reproduce. So with that being said, let's go ahead and circle the right answer. It will increase the frequency, in other words, the number of genes in the population as a whole. Excuse me, not the number. Scratch that. It will increase how much it occurs in the population. So more green frogs. Bam. Thank you very much, guys. Rock and roll.